In this video, we'll be using or applying exact values to right angle and non-right angle trig. Or in fact, it would just be right angle trig in this case. But you can use exact values in quite a few different ways. You can use it for sine rule, cosine rule, the area of a non-right angle triangle, Pythagoras, all that kind of stuff. So expect to see these exact values popping up wherever you use trig. So this will be the non-calc part of your exam. So you need to be able to do this without using a calculator. So we have no calculator in the situation, we just need to solve it. So find the exact value of x in each case. We've got x here and we have x over here. So looking at this example, we need to get x. We have this angle here, we have this side length here, and we have a right angle. So I'm thinking right angle trig, as we know angles and we know sides, and we want to find another side. So let's label our triangle. We've got, this is our angle here, 30 degrees, so this will be the opposite side, and this will be the adjacent side, because this is opposite the right angle, that's the hypotenuse. So what right angle trig ratio uses O and A would be tan, because of TOA. Write it out. Tan theta is equal to opposite over adjacent. Sub in our values, tan 30 degrees is equal to 7 over x, okay? And what we can do is we can swap. We know that little shortcut now, tan 30 degrees. And we know tan 30 is equal to root 3 on 3. So it's 7 divided by root 3 on 3. Okay, now when we're dividing fractions, we know the keep, change, and flip. So this is the same as saying, I'm just going to go over here, x is equal to 7. So we keep the 7. Oh, let's just wait for that to load up. There we go. There we go, keep the 7, change the divide to a times, and then flip, or take the reciprocal. And we get an answer of 21 on root 3, like that. If you want to rationalize the denominator, we need to times top and bottom by root 3. So this will become 21 root 3 on root 3, on 3, sorry, which becomes 7 root 3 centimeters. We can put that in our diagram up there, 7 root 3 centimeters. Beautiful. Okay, now we finished that problem there. We're going to have a look at this one over here. We have an x, we have an angle, it's right angled, we have another angle, and we have a side here. Now we want to establish what x is. So I usually work from this triangle first and then use any clues you may have to any adjoining triangles. So we know that we'll be able to work out this side length, for instance, using right angle trig here, right? We've got an angle, we've got a side, that means we can work out the other side. So that's useful. And here we have x and we have 45 degrees. So let's work out that hypotenuse in this case on this side. And let's just call it, y maybe. And let's find out what y is equal to. So y, let's use our right angle trig. This is going to be another tangent. So we write tangent 60 degrees is equal to opposite over adjacent. Therefore, y is equal to 5 tan 60 degrees. And I'm going to write that on my diagram. You don't have to do that if you don't want. Now it's best to keep that because we are trying to find the exact value case. So 5 tan 60, which I've just put here. And now we're going to find out what x is. So the exact value for x goes like this. We know that we've got an angle here, opposite and hypotenuse is so. So we're going to use sine 45 degrees is equal to opposite, which is x, divided by y. Okay. Now we can rearrange. We need to get x by itself. So let's go x is equal to sine 45 times by y, which is 5 tan 60 degrees. And now let's plug in the exact values that we know. Sine 45 degrees is root 2 on 2. And 5 is 5 times by tan 60, which is root 3. And let's bring together our surds. Okay, let's just wait for that to load up. Here we go. Bring together our surds. Root 2 times root 3 is root 6, which can't be simplified. And we've got 5 divided by 2, and we'll just keep that as 5 divided by 2, can't be simplified. So x is equal to 5 root 6 on 2 centimetres. There's our final answer.